Welcome to month 2 of the QA Engineer track at Bistec Hearts Academy. Last month you built the foundation, systematic manual testing, test design techniques, and professional defect reporting. You proved that you can find bugs methodically, that you can write test cases other people can execute, and that you can communicate what you find with precision. This month we take the next step. You are going to make your tests run automatically on every code change without you having to click through the application yourself. By the end of today, you will have a working Playwright test suite running inside a CI/CD pipeline. That is a real industry standard deliverable. Here is how today is structured. We have 4 hours and all of them are hands-on. The first hour covers automation fundamentals, what to automate, what to leave manual, and how to get Playwright installed and configured correctly. Hours 2 and 3 are the challenge. You will build your actual test suite against the ShopEasy e-commerce platform, the same application from month 1, automating the 20 most critical test cases. Hour 4 is the payoff. You run the suite, we review the code, and we talk about what you learned. Your goal for today is 20 or more automated tests, structured with the page object model, running cleanly inside a GitHub Actions pipeline. That is a portfolio quality artifact, the kind of thing you can show in a job interview. 5 objectives for today, each one concrete and measurable. Setting up Playwright means more than running one command. You will configure browsers, set up the folder structure, and write a base configuration that supports cross-browser runs from day 1. Applying the page object model is how you build a test suite that does not collapse when the UI changes. You wrap each page in a class. When the button ID changes, you fix it in one file, and every test that uses that page gets the fix automatically. Handling real UI patterns, forms dropdowns, models, dynamic content, with Playwright's auto-weighting locators, no sleep statements, no fragile timing hacks that fail on a slow CI machine. Writing data-driven tests means externalizing your fixtures, so the same test flow covers many input variations from a single JSON file. One function, many scenarios, and wiring tests into CI/CD means GitHub Actions runs your suite on every push. If a test is not running in CI, it is not protecting the product. Not everything should be automated. This is a judgment call, and good QA engineers make it explicitly. Strong candidates for automation are scenarios that run every release, regression checks, because the manual effort compounds over time. Critical business flows where a failure before release is unacceptable. Stable UI with predictable data, because volatile interfaces make automation maintenance expensive. Cross-browser validation, because no one runs manually through Chromium, Firefox, and WebKit on every build. And tedious repetitive checks where executing manually adds no insight. Your time is better spent on exploratory testing. Keep these manual, one-off exploratory testing where you are actively thinking about what could go wrong and using your judgment to probe. Visual aesthetics and usability, where a human eye is the sensor and no assertion can replace it. Rapidly changing UI, where the cost of updating automation exceeds the cost of running it manually. And anything that runs so rarely that the return on investment is negative. The ROI calculation is simple. Automate when manual time multiplied by the number of runs per year exceeds the cost of writing and maintaining the automation. A flaky automated test, one that fails randomly without a real defect, is worse than no automation at all. It costs CI time, it destroys developer trust, and it erodes your credibility as a QA professional. The test automation pyramid tells you where to invest your automation effort and why. At the base, unit tests. Cheap, fast, isolated. They test individual functions and components without a browser or a database. Run them on every file save. They should complete in seconds and give you immediate feedback. In the middle, integration tests. These check service boundaries, API contracts, and interactions with a real database. Run them on every push. They are slower than unit tests, but still much cheaper than browser tests. At the top, end-to-end tests. Full browser flows. Slow and expensive. Reserve them for the critical paths that can only be verified by actually opening a browser, navigating through the application, and asserting on what the user sees. This month we are building the top layer. But the pyramid has an important implication. If a scenario is already covered by a unit test or an integration test, do not duplicate it at the E2E layer. Every E2E test is expensive. Use them for the flows that matter most, and that require a browser to test properly. The inverted pyramid, heavy E2E coverage with thin unit tests, is a warning sign. It produces slow CI, a flaky pipeline, and low confidence because you are testing everything through the most expensive and fragile layer available. Why Playwright over other automation frameworks? Several reasons that matter in real projects. Auto-waiting. Playwright locators wait for elements to be actionable before clicking, typing, or asserting. You do not write sleep statements. You do not guess a timeout. Playwright waits automatically, which makes your tests faster and more reliable across different machine speeds. One API, 3 browser engines. The same test code runs on Chromium, Firefox, and WebKit with a single configuration switch. You get cross-browser coverage without maintaining separate test suites for each browser. A built-in test runner. Parallel execution, automatic retrieves, shared fixtures, and HTML reports come out of the box. You are not assembling a framework from separate pieces. The trace viewer is time travel debugging for failed tests. Every action is recorded with a DOM snapshot, console output, and network log. When a test fails in CI, you download the trace and replay exactly what happened. Codegen lets you click through your application, and Playwright writes the test scaffold for you. Use it as a starting point to get locators and action sequences, then refine the output into a proper test. Getting started takes 2 commands. npm init playwright at latest sets up the project and downloads the browsers automatically. Then npx playwright test runs your suite. Your project structure is a design decision that will either help or hurt you as the suite grows. The tests folder is organized by feature, auth, products, cart, checkout. This mirrors how users think about the application, not how it is built internally. When a new engineer joins and needs to find the checkout tests, they go to the checkout folder. It is immediately obvious. The pages folder contains your page object classes, completely separate from the tests. When the UI changes, you update one file in pages. Every test that imports that page class gets the fix automatically. The test data folder holds JSON fixtures. Adding a new test scenario means adding a row of JSON, not writing a new test function. Non-technical team members can contribute by editing the data file. Playwright.config tease at the root is your single source of truth for browsers, retrieves reporters, and base URL. One file governs the entire suite's behavior. The page object model is the design pattern that separates where elements are from what you do with them. One class per page. The login page class knows where the email input is, where the login button is, and how to perform a login action. Tests call login page login with an email and a password. They never reference a CSS selector. They never touch a data tested directly. When the UI changes, and it will, you update the locator in one place, the page class. Every test that calls login page login gets the fix. You do not search through dozens of test files for the old selector. Tests read like plain English. When you see await login with credentials, then expect the page to have a URL matching dashboard. You understand exactly what is being tested without reading the DOM implementation. The code on screen shows a complete login page. The constructor initializes the email input and login button locators using getByTested. The login method fills the email field, fills the password field, and clicks the button. Any test file imports this class and calls these methods. The DOM structure is completely hidden from the tests. How you locate elements determines how fragile or resilient your test suite will be. Here is the priority order. Get-B-Roll is the default. It targets the accessibility tree, what a screen reader sees, and it survives styling changes, class name changes, and DOM restructuring. A button labeled Login is still found by Get-B-Roll, even if its CSS changes entirely. Start here. Get-Billable is for form fields with a visible label. It finds the input associated with the label text. It is accessible, stable, and communicates intent clearly. GetByText works for buttons, links, and headings that are identifiable by visible text. Readable and resilient to non-content changes. GetByTested is used when the application team owns a data-tested contract. Explicit identifiers added to elements, so that tests can find them reliably. Highly stable, but requires coordination with developers to maintain the contract. GetByPlaceholder for inputs without labels. Acceptable, but prefer label-based locators when labels exist. CSS selectors and XPath only as a last resort. They couple your tests to DOM structure, which means a purely cosmetic refactor breaks your tests even when the functionality is unchanged. The chain rule. Try role-based first, fall back to text or label, use tested when neither is feasible. Never default to CSS. Every Playwright test follows the same pattern, and understanding that pattern makes reading and writing tests fast. Test describe groups related scenarios. All authentication tests live under one heading. This organizes your report and lets you run just the auth tests when you are working on that feature. Test before each runs before every test in the group. Here it navigates to the login page. Every test starts from the same known state. This is essential for test isolation. Tests must not depend on each other. Inside each test, 3 phases. First, arranged, construct the page objects and navigate to the starting point. Second, act, call the user-level action. Login page, login with an email and password. Third, assert, use Playwright's web-first assertions, which auto-retrieve until they pass or the timeout is reached. To have a URL with a regex pattern checks that the page URL matches dashboard after a successful login. The test name TC1001 logs in with valid credentials, serves as living documentation. When this test fails in CI, the error message tells you precisely which scenario broke and what the expected outcome was. Notice there is no sleep anywhere. No wait for element with a guest timeout. Playwright handles all the waiting automatically. Data-driven testing separates your test logic from your test data. One function, many scenarios. The test data folder contains a login cases .json file with 3 objects. The first has valid credentials and an expected outcome of success. The second has an invalid password and an expected outcome of error. The third has an empty email field and an expected outcome of validation. Each object is one test case, described entirely as data. The test file imports the cases array and loops over it. For each case, it creates a test with a name that includes the expected outcome, runs the login flow, and asserts the result based on the expected field. 3 test cases from one loop. Adding a 4th case is 1 row of JSON. Why externalize data? 1 flow, many cases. A new scenario requires no new code, only a new row in the fixture file. Non-coders can contribute. Business analysts and product managers can add edge cases by editing the JSON without touching TypeScript. Edge cases stay visible. The fixture file is the documented contract of what the suite tests. Anyone can read it and understand the coverage. Running tests locally validates your own machine. Running them automatically on every pull request is what actually protects the product. The GitHub Actions workflow on screen triggers on pull requests to main. It checks out the code, installs Node 18, runs npm site to install dependencies from the lock file, runs npx Playwright install with deps to download the browsers in the CI environment, runs the test suite, and then uploads the HTML report as a build artifact. The if, always, means the report is uploaded even when tests fail. That last detail matters. You want the report available for debugging precisely when things go wrong. What this gives you: fast feedback before merge, because every pull request runs the full suite. Bad merges are blocked, because failing tests fail the CI check and the PR cannot merge. 2 retries in CI handle transient network flakiness without hiding real bugs. And when a test fails, the HTML report and trace file are 1 click away in the actions run. Wiring tests into CI is the step that turns a local script into an engineering control. This is what professional test automation looks like. Playwright gives you 2 tools for understanding what happened in a test run. The HTML report opens after any run with npx Playwright show report. It shows pass and fail status for every test, retry history, timing per test, and embedded screenshots and videos on failure. You can filter by status, by file, or by tag. When something fails, the HTML report is your first stop. The trace viewer goes deeper. It is time travel debugging for failed tests. Every action is recorded with a full DOM snapshot, console output, and network log. You open a trace with npx Playwright show trace and the zip file from the test results, and you can click through each action step by step and see exactly what the page looked like at that moment. Configure tracing in Playwright config ts by setting trace to on first retrieve. This means you get the full forensic record only when a test actually fails, no overhead on green runs, full debugging capability when you need it. Here is the challenge. You are automating the ShopEasy e-commerce suite from month 1. You have 30 or more manual test cases. Your job is to choose the 20 most critical, covering authentication, product search, cart operations, and checkout, and turn them into reliable Playwright specs that run in CI. 4 parts with time boxes. 20 minutes for framework setup. npm init. Configure browsers, set up the folder structure, write the base config. 40 minutes for page object model. Create the login page, product page, cart page, and checkout page classes with reusable locators and action methods. 45 minutes for test scripts. Write 20 or more tests across the 4 critical flows with proper assertions and isolated state. 15 minutes for the CI/CD pipeline. Write the GitHub Actions workflow, install browsers with caching, upload the report artifact. This is a production-grade deliverable. These are the same patterns used on real projects in professional QA teams. 5 deliverables for month 2. Your automated test suite, 20 or more spec files covering the 4 critical flows, with tests that run cleanly and independently. Your page object classes, login page, product page, cart page, checkout page. Each class wraps its page's locators and actions in reusable methods. No raw selectors in test files. Your CI/CD pipeline, a GitHub Actions YAML that runs on push and on pull request, installs browsers, runs the suite, and uploads the HTML report as an artifact. A test execution report from a green run, proof the suite works. A framework README explaining how to install, run, debug, and extend. The assessment weights test coverage and page object quality at 25 points each. Together that is 50% of your score. Code quality is 20. CI/CD is 15. Documentation and reporting split the remaining 10. Notice that reporting is only 5 points, because the HTML reporter and trace viewer come configured by default. You earn those 5 points just by leaving the Playwright defaults in place. 6 milestones before month 3. To consolidate what you learned today, add 10 more tests to push your total coverage past 30. Implement data-driven tests with CSV or JSON fixtures so you have hands-on practice with the pattern beyond the class example. Run all 3 browsers in CI, Chromium, Firefox, and WebKit, so you verify the cross-browser configuration works end-to-end. Configure the HTML reporter and trace viewer and confirm both work correctly on a real test failure. Set up screenshot and video capture on failure so you have evidence when things break in CI, and complete the official Playwright tutorials at Playwright Dev. The resources on screen are the essential reading: the Playwright documentation introduction, the best practices guide, the page object model page, the locators reference, the CI introduction, and the trace viewer guide. These are the 6 URLs you will return to repeatedly as you build real automation suites. That is month 2. You can automate now. 3 principles to carry forward. Test like a user. Use role-based locators and web-first assertions. Your tests should interact with the application the way a user does, through the interface they see, not by reaching into the DOM directly. Refactor early. Page objects pay for themselves at the 3rd test that uses them. Every test that reuses a page object class is one you will not have to update individually when the UI changes. Run on every push. If your tests are not running in CI, they are not protecting the product. A test suite that only runs locally is a convenience tool. A test suite in CI is an engineering control. Month 3 is API testing. You will learn to test the backend directly, making HTTP calls, asserting on response codes and payloads, and testing the contract between your front end and backend. Everything you learned about test design, equivalence partitioning, boundary values, and structured execution applies. You will just be testing a different layer of the system. Well done today.